In this video, we're going to talk about how to use the Pythagorean identities in order to solve and simplify trig functions. So first I want to look in on the three Pythagorean identities. Remember that the Pythagorean theorem is a squared plus b squared equals c squared. So the Pythagorean identities with trig functions works very similar. It's sine squared plus cosine squared equals 1. And then we can actually derive these other two. Tangent squared plus 1 is equal to secant squared, and cotangent squared plus 1 is cosecant squared. So this is a good thing to have memorized. You're going to want to write this down and make sure you memorize these three. Before we do that, I want to give you a little tip. Only memorize sine squared plus cosine squared equals 1. If you don't want to memorize the other two, I'm going to show you how to derive them each time. So what you're going to want to do is divide both sides by sine squared. So you take the original sine squared plus cosine squared equals 1. And then we're going to divide everything by sine squared. So sine squared divided by sine squared is just 1. Cosine divided by sine is cotangent. And 1 over sine is cosecant. And so that gives us one of our identities. So the next thing we're going to do is divide both sides by cosine squared. So we go back and we go sine squared plus cosine squared equals 1. And now we're going to divide everything by cosine squared. And remember, you can divide both sides of an equation by whatever you want, as long as you do it to both sides to keep the equation balanced. So sine squared over cosine squared is going to be tangent squared. And then cosine divided by cosine is 1. And 1 over cosine squared is going to be secant squared. And that gives us our other identity. So if you do not want to memorize them, you can do this every time. If you do this enough, you will end up memorizing them anyways. Example 2. If tangent of theta is equal to negative 8 and sine of theta is greater than 0, we want to find cosine of theta. Now remember, we've done this using the triangles. But I want to show you now how to use identities in order to do this. So let's think about what we know. We know tangent. So I'm going to write down the Pythagorean theorem that has tangent. So tangent squared plus 1 is equal to secant squared. So now what we do is we know that tangent of theta is negative 8. So I get negative 8 squared plus 1 is equal to secant squared. So 64 plus 1 is secant squared. So 65 is secant squared. And then you square root both sides. And don't forget the plus or minus. So you get plus or minus the square root of 65 is secant of theta. But I want cosine, not secant. So I just take the reciprocal. So cosine of theta is equal to plus or minus 1 over the square root of 65. And then we have to make sure we rationalize that. So you get plus or minus the square root of 65 over 65. Now we can only have one answer. So let's go back and remember what we know. We know that tangent of theta is equal to negative 8. And we also know that sine of theta is positive. So based on both these things, we're going to be in quadrant 2. Because tangent's negative and sine is positive. So in quadrant 2, cosine is negative. So our answer then is cosine of theta is equal to negative root 65 over 65. Now I want to show you how to take the same problem and solve it using our triangle way. Alright, so we have tangent of theta is equal to negative 8. And we have sine of theta is positive. So based on both of these, again we're in quadrant 2. So I go ahead and I draw my triangle. And tangent is negative 8, so I need that as a fraction, so negative 8 over 1. So it's opposite, so it's 8, and then adjacent is 1, and it's going to be negative for the 1 because you're in quadrant 2. And my goal is to find cosine. So I want cosine of theta, which is adjacent over hypotenuse. So I do need this value here. So again, we go 8 squared plus negative 1 squared is c squared. And we're going to go ahead and work that out. So we get c is the square root of 65. And then we just have to find cosine. So cosine of theta is negative 1 over square root of 65. And then you rationalize it. And we get negative square root of 65 over 65. I do prefer the triangle way. I think it's much easier, but there is an actual algebraic way to solve these problems. Okay, so on your own, I want you to try these, and you can do them either the algebraic way or the triangle way. Okay, so I'm going to go ahead, I'm just going to solve it the triangle way. So I have cotangent is negative 3, and cosine is less than 0. So now I know that tangent is negative and cosine is negative, so that's going to put me in quadrant 2. So I go ahead and I draw my triangle. And I know cotangent, so this is over 1. And cotangent is going to be x over y. So I get negative 3 and a 1. I have to go ahead and find c. So c is the square root of 10. And then I want tangent. So tangent of theta is going to be negative 1 over 3. I also want cosecant. So cosecant of theta is r over y. So it's going to be the square root of 10 over negative 1, which is just the negative square root of 10. Okay, now let's do part B. So I know that sine is positive, and I know cosine is positive. So based on this, I know we're going to be in quadrant 1. So I go ahead and draw my triangle. And sine is going to be y over r. So I get 1 and a 6. So I need to solve for this side right here. Okay, and I get b is the square root of 35. And I know it's positive because we're in the first quadrant. And my goal for this problem was to find cotangent. So cotangent of theta is going to be root 35 over 1, so it's the square root of 35. And I also want to find secant. So secant is r over x, so it's 6 over the square root of 35. And then you want to go ahead and rationalize that. And you get 6 radical 35 over 35.